Hey guys, welcome back to Math from my desk. In today's video, we'll be taking a look at President Garfield, the 20th US president's proof of the Pythagorean theorem. So let's go ahead and start. So first we're going to go ahead and build a right triangle with side length AB. So we have side length A, height A, and length B, and the hypotenuse is C. This is a classic right triangle. So we have our 90 degrees angle here, and let's go ahead and call this angle right here theta. And now the interesting thing that we're going to do is what President Garfield did, is we're going to go ahead and build a congruent triangle on top of this. So we're going to have side length B over here, collinear with this A. And then we're going to have the A over here, and the hypotenuse C over here. So this is 90 degrees, and this angle here is also theta. It is congruent with this one. So right now, these two triangles are congruent to each other. All right. And then we're going to go ahead and draw a line to connect the endpoints. And what we notice here is that this right here forms a trapezoid. So this is going to be interesting later, and this is going to be used in the proof. But first, before taking a look at the area of the trapezoid, you're going to want to find the value of this angle right here. Let's call this angle simply beta. So we want to find what beta is. And so this is very doable, because what we know from this right triangle here is that we have 90 degrees over here first and foremost. And we know a right triangle, all of its angles sum to 180 degrees. So what this means is that theta plus this angle right here, let's call that question mark, have to add to 90 degrees. So question mark right here is equal to theta minus 90. Or sorry, 90 minus theta. So all of these angles right here will also sum up to 180 degrees, because it's like this, 180 degrees. So what this means is that theta plus beta plus 90 minus theta have to equal to 180. And so the thetas cancel out. We're left with beta plus 90 is equal to 180. Then we subtract 90 from both sides, and we're left with beta is equal to 90. So we figured out that this angle right here, beta, is equal to 90 degrees. So this triangle with side length C is also a right triangle. All right. So now what we're going to do is we're going to go ahead and find the area of this entire trapezoid by using the formula for the area of a trapezoid. So first we're going to go ahead and take the height of the trapezoid, which in this case is A plus B, as we can see here, A plus B. And we're going to multiply that by sort of the average of the heights. So the average of the heights is going to be 1/2 times A plus B, because it's sort of like it's taking the mean of the two heights, A plus B. And so we can rewrite this, since we have two A plus B's, as 1/2 times A plus B squared. And what this is equal to is the sum of all the areas of these right triangles. So first of all, let's go ahead and take a look at this right triangle right here with sides A and B, which is going to have the same area as this right triangle because we made them so that they're congruent to each other. So the area of this triangle is going to be equal to 1/2 times A times B. So this is simply the area of a right triangle. However, since we have two of these right triangles, we're going to go ahead and multiply that by 2. And so the 1/2 and the 2 will cancel each other out, and we're left with AB. And to that, we add the area of this right triangle, which is 1/2 times C, the height, times another C, the length, so 1/2 C squared. All right. So now what I'm going to do is I'm going to want to get rid of this 1/2 right here. So we're going to multiply both sides by 2. So this right here simply gets rid of the 1/2 as I wanted. So we have A plus B squared is equal to, we have 2 times AB, so 2AB, plus 2 times 1/2 C squared, which is simply plus C squared. Now what I'm going to do is I'm going to go ahead and expand this ab plus squared, which we know gives us a squared plus 2ab plus b squared. And that is equal to 2ab plus c squared. Now this is where you might start seeing the Pythagorean theorem if we subtract 2ab from both sides. We're then left with the famous formula a squared plus b squared is equal to c squared. So this is true for a right triangle with side length a and b and hypotenuse c. Thank you for watching this video. This is President Garfield's proof.